Hey everybody, our first video of Calc BC. There's different ways you can go about this. One, you can quickly go through the video and copy everything down at once, and then you can go ahead and watch the video as I work through it. Or you can pause the video throughout and copy as we go through. Either way, your best bet is to print out all of the note sheets prior to watching the lectures, okay? All right, so here we go. We're going to begin our Chapter 2 review, the first part dealing with differentiation. We're going to look at the limit definition of the derivative. We're going to remind ourselves how to take the derivative and how to find the tangent line, etc. Okay? So this first diagram here is just showing a curve. And it's this curve f of x, and it's reminding us how to find the slope, right? So how to find the slope is change of y over change of x, okay? Where our change of y is simply that f of x naught plus delta x minus f of x naught, and we're going to divide that by our change in x, which is simply represented as delta x, okay? As we move forward, we're going to get into our limit definition. Okay, so our limit definition, which is dealing with f prime, okay, of a derivative, the limit definition of the derivative, is simply the slope of a tangent line at x. Okay, so what we're really looking at here is the derivative of f at x is given by this limit definition of the derivative. Okay, so f prime is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x, that's your change in y, over delta x. Okay, and this works so long as the limit exists. Okay, so for all of x for which the limit exists, f prime is a function of x. So we can find the derivative is what it's saying. Okay, so we're going to use the limit definition to go ahead and find the derivative. Okay, so I'm going to zoom in a little bit here just to kind of get us started, and then I'll zoom back out. Okay, so we're going to use that limit definition to find the derivative of this function f of x is equal to x squared plus 2x. All right, so here is our definition. F prime is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So this is our slope formula, which we are familiar with. Okay, and now all we're going to do is we're going to use our function of f of x and plug that into our formula, okay, for x plus delta x. So we're going to plug that in, x plus delta x squared plus 2 times x plus delta x, that takes care of this part, minus f of x, that's this part. And then it's all over delta x. So now we're just going to clean things up right here in this step. We're going to square this binomial, we're going to distribute this 2, and we get this long line here. I'm going to distribute that negative as well. Okay, so when we clean it up and combine our like terms, we're left with the limit as delta x approaches 0, where delta x is squared plus 2x delta x plus 2 delta x all over delta x. So we can factor out that delta x, and what we should notice is now we've got these delta x canceling one another, and we've simplified that limit. Okay, so now that we're down to this step, we can go ahead and substitute directly delta x equaling 0. All right, so now when we go ahead and we substitute, 0 goes in for delta x, and we go ahead, we clean it up, and we get our derivative. So f prime of x is really equal to 2x plus 2. This page here is just kind of a cheat sheet for us. You can find this in your book as well, all right? It's on page 136, but here it is in our notes, all right? So it's just reminding us some differentiation rules, certain derivatives, all right? Our constant rule, our single power rule, some derivatives of trig functions. These are the most common ones here. And then don't forget about that chain rule. Okay, where we take the derivative and then we also have to take the derivative of what's inside. We'll go through an example of this, but it helps to kind of reacquaint yourself with all of these derivative rules. Okay, all right, so continuing on, different notation you're going to see for derivatives are all up here, right? F prime, dy dx, y prime, d dx of f of x, that's saying we want to take the derivative of f of x, and then this d sub x of y, all right? That's saying the derivative of that function of y, okay? So one thing to kind of keep in mind is differentiable versus continuous and continuous versus differentiable. They're not necessarily interchangeable. Okay, so if we have our graph, which is our absolute value graph, f of x equals the absolute value of x minus 2, we can see that it is not differentiable at x equals 2. We've got this point right here. We can't take the derivative there, all right? Because the derivative from the left and from the right are not the same, okay? So the slopes of these are different. Coming from the left, we have a negative slope. Coming from the right, we have a positive slope. So since they're not the same, it is not differentiable at x equals 2. Okay, so one thing that's very important here is a function, if it is differentiable, it's continuous. That's key, but if it's continuous, it doesn't necessarily mean it's differentiable. All right, so make sure you star that aspect. Let's take a look at that concept right now. Okay, so example 2, we're given this function f of x equals the absolute value of x plus 3 plus 1. So hopefully we're comfortable graphing this. Okay, so we shift to the left 3 units and we go up 1, and then we've got our absolute value function. All right, so let's ask ourselves, well, where is f of x continuous? Well, if I can go ahead and not lift up my pen the entire time, we know it's continuous. So where is it continuous? It's continuous on the entire interval from negative infinity to positive infinity. Okay? Where is f differentiable? Or maybe a better question is, where is f not differentiable? So what we should notice is f is not differentiable at this point right here, because to the left of that x equals negative 3, right, we've got a negative slope. And to the right, we have a positive slope. So since the derivative on the left of x equals negative 3 is not the same as the derivative on the right of x equals negative 3, it is not differentiable at x equals 3, or negative 3, sorry. Okay, so how can we go ahead and say that? Well, we can say, where is it differentiable? Well, it's differentiable from negative infinity to negative 3 and in union with negative 3 to positive infinity. Note, I'm not including negative 3 in my interval. Okay, the next thing we're going to look at is this third example here, where we're given f of x is equal to the square root of x minus 2. One thing I want you to kind of get used to is let's rewrite that function, okay? Because when we're going to take the derivative of something or think about the tangent line, it's much easier to do so in this format. Okay, and that's something we're going to do often. So the square root of x minus 2 is really equivalent to x minus 2 raised to the 1/2. Okay? All right, so our first goal is to find the equation of the tangent line through this point. All right, so when I see find the tangent line, I'm thinking take the derivative, okay? Now, we just talked about the limit definition. The only time you have to use the limit definition of a derivative is when the directions say so. Otherwise, we can use our differentiation rules, okay? One thing we don't want to forget is our chain rule. Okay, so here we go. We're going to take the derivative. So when we take the derivative, remember this power comes down in front, so that's our 1/2 times x minus 2. And what do we do this power now? We subtract 1. So that's where we get negative 1/2. Not forgetting about our chain rule, we take the derivative of what's inside, and it just so happens that it's 1. So we have to remember to multiply that by 1. So when we clean this up, now we can write it back into that square root mode, and we get our derivative, 1 over 2 times the square root of x minus 2. Okay? But it wants us to find the equation of the tangent line. So now we found the equation of our slope, right? So this represents our slope. Since we want it at this certain point, we now have to plug in our point. Now there's only an x value to plug into. So we want to find, that should say f prime of x, okay? F prime of 6. And when we evaluate f prime of 6, we get 1/4, all right? So then finally, the last step, so this represents our slope at that point, okay? And now we're going to write the equation of our tangent line. I prefer you write it in slope point or point slope form, okay? So since our point is 6, 2, all right, we've got y minus 2 is equal to 1/4, which is our slope, times the quantity x minus 6. Now, when we start using our calculator more, the only thing I would change is just get y by itself. No need to clean it up any further, all right? The next thing we're going to talk about is using our calculator. I'm going to talk about this more in class because there might be some issues. If you understand what that table is showing you, feel free to play around with your calculator, and we'll address it in class when we meet next time. All right, so we're on to our last example. Again, it's review. Well, the whole thing has been review, hopefully this far. So we want to find the limit if the limit exists. Now, one thing we have to keep in mind is this little reminder here, okay, dealing with absolute values. So if the absolute value is equal to x, or it equals x, if x is greater than 0. So if x is positive, the absolute value of x is simply x. If x is negative, then the absolute value of x is equal to the opposite of x. Don't think of it as negative x, think of it as the opposite of x. Okay, so this is going to come into play. So we want to find the limit as x approaches pi from the left. So that's the key right there. We're approaching pi from the left, of x squared minus pi squared over the absolute value of x minus pi. Okay? So our goal is to get rid of this absolute value stuff, all right? So we have to think about that. But first, if we take a look at the numerator, that's a difference of 2 squares, so we can factor that. So we're going to take the limit as x approaches pi from the left of x plus pi times x minus pi, and now I'm going to use that reminder. Okay, so if we're approaching pi from the left, okay, if we're approaching pi from the left, that means this x value is less than pi because we're approaching it from the left. Okay, so if we're thinking about it this way, we can think about it as here's pi, and I'm approaching it from the left, so that means x is going to be less than pi. So since that's the case, we are using our little reminder that it's going to be, this quantity is going to be negative, right? It's going to be the opposite. So now we can drop the absolute values, and it is equal to the opposite of x minus pi. Okay? So now that we have this, it's all in factored form, we can cross out the x minus pi's, and we clean up our version right here. So now we're looking at the limit as x approaches pi from the left of the opposite of x plus pi. And now we can substitute and evaluate this limit. And when we do so, we're going to end up with negative 2 pi. If you have questions, make sure you mark this in your notes, and we will address this at the beginning of class next time we see each other.